Students, today we are starting a new topic called single slider crank chain mechanism and the inversions of single slider crank mechanism. In the last class, we have discussed about the 4-bar chain mechanism and its inversions, that is a beam engine, coupling rod, and watt straight line mechanism, and the double slider crank mechanism and the inversions of double slider crank mechanisms. That is Oldman's coupling and Scott York mechanism, and elliptical rammer. Now, coming to the point, single slider crank mechanism. The single slider crank mechanism, it is just a modification of 4-bar mechanism. That is the continuity of 4-bar mechanism. We are just modifying the sum elements. In this, one sliding pair and 3 turning pairs are there. And coming to double slider means 2 sliding and 2 turning. Here, 1 sliding and 3 turning pairs are available. This type of mechanism is converting the rotor motion into reciprocating motion, and at the same time vice versa also. So in a slider crank mechanism, the links, so this is a schematic diagram, a slider crank mechanism. In this, the links 1 and 2 the links 1 and 2, one is called the fixed one and 2 is called the crank. These 1 and 2 and 2 and 3, see here 1 and 2 is rotating and 2 and 3 and 4 will forms the turning pair, and at the same time 1 and 4 will forms the sliding pair. Sliding means it is already a direction of this one, so this is called the sliding pair, 4 and 1, and 1 and 2, this is 1 2, this is called the crank. Crank is rotating 360 degrees, so it is called a turning pair, and the crank to connecting rod, it is also the connecting rod is also rotating about with respect to crank, so it is also a turning pair. And at the same time, the link 3 and 4, which are all having the cross heads, so this is forming the turning pair, and finally it is a sliding pair or the movement of the piston. So this is the guides, the movement of the piston is in reciprocating. So 1 2 1 and 2 and 2 and 3 3 and 4 it forms turning pair, and 4 and 1 it forms sliding pair. So the single slider means sliding is 1. The double slider means 2 slidings are there. Whatever the remaining, only 2 turnings are. That's why the name, in the name itself you can easily say. So how many number of slides are there? Okay. That. What about the inversions? The inversions of single slider crank chain is of results in the following mechanisms. One is pendulum type or bull engine and oscillating cylinder engine, Gnome engine, crank and slotted lever mechanism, and Whitworth quick return motion mechanism. In the exam point of view, the problems and the derivations or they explain the things. They may ask from the crank and slotted lever quick return and the Whitworth quick return. These two diagrams we need to remember for everything. So these two topics are very important. The crank and slotted lever quick return and the Whitworth quick return. Why the names of quick return that we will see in the diagram. Next, coming to pendulum pump or bull engine. This is called the pendulum and bull engine. In this mechanism, the inversion is obtained by fixing the link 4 cylinder or a link 4. So by fixing the how many number of cylinders are there means this is one cylinder and this is the another cylinder. We are fixing the elements. So the in the diagram also the cylinder or link 4 are fixed here and here. See the matter related to the diagram is very easy. Since we if you remember the diagram, just explaining the what are the elements are available in the diagram. That is enough to narrate the session. So just firstly we have to remember the diagram, how the pendulum diagram. Just by hearting or a number of times practicing the diagram is very easy. So in the first pendulum time, we are fixing the elements link 4 or cylinders, and this in this case, when the crank is nothing but always you can see remember the link 2. So in this case, when the crank this rotates, the connecting rod which is connected to the crank will always oscillate about the pin which is pivoted to the fixed link 4. So see here, whenever the crank is rotating, this link of connecting rod will be oscillates like this. And at the same time, if it is was there, the piston rod, whichever is connected to the crank, it may upward and downward. So this means the crank is rotating, against which connecting rod is oscillating, and finally due to these two connections the piston is reciprocating. So reciprocating to or rotary to reciprocating or reciprocating to rotary. This is the uh, vice versa conditions also. The main example for is duplex pump which are used in the boilers to feed the water supply. So how the animation of this slider crank mechanism of inversion, that is pendulum pump or bull engine, we will look it into after. Let us see. This is the animation of single slider crank mechanism. This is the animation of single slider crank mechanism. This is rotary crank, the orange color. It will form the connecting rod through reciprocate. So rotary to reciprocate. Now It is called pendulum type. See, this is the red color will indicates the crank, against which the blue color is of oscillating, so that the pistons are reciprocating. Next one is the oscillating cylinder. Oscillating cylinder. In this mechanism, which is used to convert the reciprocating motion to a work unit. Actually, in the previous case, we have studied about the rotary to reciprocating. It is a specialized one that reciprocating to a rotary option. So, in this also mechanism, link 3. In this, the link 3 forming the turning tail, which is to be fixed, and the link 3 corresponding to the connecting rod will form the steam wheel. So, in the previous case, we are framing the fixing the first link in any of the previous cases, but here we are fixing the element called connecting rod. So, this is a very different thing. We will know what the topics we have discussed. This is some different thing. So, here also the reciprocating to rotor. In the previous cases, we have fixed only the link 1. Here we are fixing the connecting rod or link 2. Then when the crank will rotates, the piston attached to the piston rod, which is the link 1, reciprocates, and the cylinder, which are of link 4, will oscillate about the pin, which is fitted to the fixed link. So whenever the crank is rotating, the piston rod which is connected to the crank, previously cases, piston rod, the crank is connected to the connecting rod. Here we are fixing it. So there is no movement in the connecting rod. What are the other elements is to be moved? The piston rod is to be moved. So by the rotation of the crank in the 360 degrees, the piston will move in the direction of like this. So with that, the cylinder is also, or what is the piston which is inside of the cylinder will move reciprocating. So this is the oscillating cylinder. So here, which one is the oscillating means? Whenever the piston rod is moved in this direction, the cylinder will move a slight oscillation. At the same time, internally, the piston is moving in the reciprocating direction. These are the three elements. One is crank 2 is rotating rotary. With that, the cylinder is oscillating, and the inside of the cylinder, the piston is this. So this is the condition, and how the animation will be. So this is the animation of it. See, this is the crank. and what is the fixed one? The piston rod is reciprocating, but the cylinder is oscillating. The moment. Next, what is the next thing? Next thing is rotary internal combustion engines. So sometimes, that means in the olden days, the rotary internal combustion engines were used in the aviation. In the olden days, the IC engines are used in the aviation, that means the flights. Okay. But nowadays, gas turbines are used in the place of IC engines in order to move the highest speeds, and at the same time, the fuel supplying is more requirement. So the gas turbines are very useful for giving the higher energy. So it consists of 7 cylinders in one place. So if you see the diagram here, 7 cylinders are there. That is 1, 2, 3, 4, 5, 6, 7. These 7 cylinders which are revolving about a fixed center. This is called the fixed center. This is called the fixed center D, and while the crank 2 is fixed. Here also the crank. So for the moment of the piston arrangement, the crank is to be linked. So in this mechanism, when the connecting rod is rotates, the piston reciprocates inside the cylinder, which follows the link 1. So if you see the animation, it will clearly gives the full information. So let us see. This is the animation of thing. See here. Three, four, five. So here it is a 5 engines, but in the rotary internal combustion engines or Gnome engines, having same crank. This is the internal portion of the cylinders. So this is the fixed frame or crank. These connecting rod, the crank is connected to the connecting rod. We will show it in the orange color. So when it is connected to the connecting rod and the connecting rod is rotating, which is attached to the crank, pistons are connected to a single connecting rod. To a single connecting rod. So in this, for a single action, there is a lot of energy will be developed. So see here, these two are every engine. They are in a certain position of strokes. One is suction, and the final here it is combustion or exhaust. This is the combustion, and it is going for the compression. So they are the different levels of their own positions for a single rotation of the country. Okay. Next, the crank and slotted lever quick return mechanism. This is very important. Quick return mechanisms, Whitworth and crank and slotted lever. These both are very important. So in this mechanism, mostly used for shaping machines. This mechanism is mostly used for shaping machines, in slotting machines, and in rotary, that is in IC engines also, we are using. Most of the cases, the best example is shaping and the slotting machines. In this mechanism, the link AC, this is the diagrammatic representation. In this mechanism, the link AC, it is link 2, link 3, sorry, this link 3. This is the AC, which is called a fixed one. Running the turning pair, which is fixed, and the link 3 corresponds to the connecting rod of the reciprocating machine. So the link 3, which is of AC, will form the turning pair and it is fixed one. In the driven crank, that is CB, the driven crank CB will revolve with uniform angular speeds about the fixed center C. So with respect to C, the link or the crank CB, which is of the positions, so we see here, the CB will rotates about the center C. The sliding block is attached to the crank pin at B. This is called the sliding block. This is a very which is already sliding. Sorry, this a sliding block which is connected at the crank pin, which slides along the slaughter bar AP, and this will causes the AP to oscillate about the filter. So this slotted block is common for the AP. There is a slotted bar. AP is the slotted bar, and the small slotted block is attached to the point B, which is common center for AP slotted bar also. Whenever the movement of this slotted bar in the direction of this, the movement means the crank CB is rotating with the block which is connected to the slotted bar, which makes the tool which is of at the ram. See here, the ram is there. PR is connected to the ram. So simply we can say that the movement of this slotted bar in the direction of like this, the ram will move in the forward direction. This forward direction is attached to, and when it is come back to back, that is the ram will move in the backward direction. That is called return stroke. So why the meaning of quick return means the return of the slotting bar will be very faster the return of the slotting bar. This is this one. So the return of the slotting bar will comes very faster in a back manner than that of the forward manner. So the line of stroke of ram, it is from position R1 to R, which is perpendicularly to the AC. So this is perpendicular to AC. So the line of stroke is R1, R2, which is perpendicular to this. So the angle of rotation at the time of cutting stroke to the time of returning stroke. See here, what are the P1, P2 means maximum positions of this slotted bar. The P is the end of this slotted bar. The maximum position and the minimum position is P1 to P2. And the ramp positions is R1 to R2. Here the time of cutting stroke. The cutting stroke is in the forward direction only. So the cutting stroke of to return stroke is the angle. Cutting stroke means what? So whenever the slotted bar is moving like this, so the moment or the moment of the angle is beta, and the returning means, so from here to it has to come back. So that means returning means it is an angle called returning alpha. So beta by alpha is equals to beta by. So what is an angle of the beta mean? The angle of alpha means the total angle is 360. The moment of the crank is 360. If you left off the beta angle, the remaining one is the alpha. So 360 minus beta is alpha. Or otherwise, the alpha left of the angle of alpha among 360 is beta. So we can write it the formula in these two forms, whichever is the applicable one. So quick return means during the return of the slaughter, is a quicker manner. So we will call it as a quick return mechanism. So this is the crank and slaughter mechanism. Here, this is the ram. The red color indicates the ram. This is the slotted bar. See here the point of block, that is slot block, which is rotating 360 degrees about the crank, and this slotted bar is oscillating. The slotted bar is oscillating. If you see, the return of these is very faster. See, whatever the forward stroke, when compared with the forward stroke, the return is very fast. So that's why we are calling quick return mechanism. So this is a slotted crank. This is the crank, and the blue color is the slaughter. So see, crank and slotted lever quick return mechanism. You see, it's a very quick. When it is going forward means it is off. And the next last one, Whitworth quick return mechanism. This is also found by Whitworth. So the name of the person is alerted to the mechanism. This mechanism is mostly used in shaping and slotting machines. This is also the same conditions now. Here, this is the last and important thing also. In this mechanism, the link to or the fixed link, same in the same manner, but it is of B section, the single slider. This is of B section, and here it is C, and here it is A, and by connecting these two, the blocker is presented. This blocker lever is connected to, this is P, this is, this rotation is 360. With that, this slotted bar is connected to the RAM. So this is RAM. The RAM is moving forward and returning in the backward in the faster manner. The link AC is fixed one, and C, AC link is perpendicular to the travel of the track. So, like this, perpendicular to the travel. In same case, you just remember the single slider and follow the things. This is Whitworth quick return mechanical. The link to the link to the link to is correspondingly to a crank in a reciprocating steam. So here it is a link to, this one is fixed, and the crank B DP and connecting rod. So this is the arrangement will be like a reciprocating steam engine. The driving crank CA. See CA. This is the driving crank. This driving crank is rotating at a uniform angular speed. The slider 4 will attach it to the crank pin at the slider, which oscillates about a pivoted point. So whenever the movement of this, that is the crank or the driving crank, the slider will oscillate like this about the point B. The connecting rod PR, the connecting rod PR is carries the ram's head, or this is the connecting. So whenever if you see in the diagram, whenever the slaughter is moving in the upward direction, automatically the slaughter which are at the point P will moves in the downward direction. Whenever it was moved to downward, automatically the connecting rod will move in R. See, when it is coming to upper, this will move downwards. Automatically the length of the connecting rod will pushes the ram towards the cutting stroke. So this cutting stroke by the tool. So that's why which carries the cutting tool is to be fixed. The motion of the tool is constrained along the line or the, this is the movement of the tool. This is the movement along this straight line which is passing through the. So whenever if it is like this, when it is comes to down. So like this the operation is movement. So whenever it is there, the position will be go in the forward direction, and then when it is coming to backward, the slaughter is coming to backward, this end P end will move in the, what is the direction? backward direction. Whenever it is coming to back, the connecting rod also will move ram towards the back side. So this side of motion we will call it as a return stroke. So this movement of the ram is perpendicular to what? Perpendicular to the fixed link, that is CD. So in the previous case of a crank and slotted lever mechanism, there the rotation, the motion of the ram with respect to the fixed one is which one? AC. So when the driving crank ACA moves from the position CA1 to CA2 through an angle alpha in the clockwise direction, the tool moves from left hand side to of its stroke to right hand side. That we discussed just now. So finally, what we are getting here, the time of cutting stroke to the time of returning stroke. The time of cutting means cutting here it is alpha. Since crank is moving up or the slaughter is moving in the direction of up and here it is from the down, then only the connecting rod will move in the forward direction. What is the angle of rotation here? So the movement of the slider is like this. What is the angle here? It is alpha. Alpha. There only the crank move or the ram moves in the forward direction. So that is alpha. Whatever the remaining element by beta. So alpha by 360 minus alpha or 360 minus beta by beta. This is the quick return mechanism. So here what is the final thing is the slaughter which is connected to the end point A by the rotation of the crank will move the slaughter or the driving crank is rotating, the slaughter bar is or oscillating in the direction of at P is like this and at A is will be like this. So due to that the ram moves in the forward direction. When it is comes to again beta angle of rotation, the ram will move backward direction very fast. So the animation of this we will see when we will go for the final session. See here. So this is the today's class in the final session of the simple mechanism. Firstly, the double single slide crank mechanism is divided to 5 varieties. One is pump or bull, pendulum pump or bull type engines. And the second one is oscillating cylinder engine. And the third one is crank slider, crank and slaughter in the quick return mechanism. And the fourth one is rotary internal combustion engines or fuel engines. And the last one is Whitworth quick return mechanism. Then finally we will see how the animation of this Whitworth quick return mechanism. This is the animation. This is a Whitworth. Mostly look like both are same. See, this is the slaughter. The slaughter is rotating 360. In the single slider crank mechanism, it is just like an oscillating.